In this video, we'll be looking at Chapter 5, Section 3, where we talk about covalent bonds. Covalent bonds form when two atoms are sharing their electrons. Okay, so it's different than ionic bonds because instead of taking them and having positives and negatives, we're going to be sharing covalent bonds. They usually form between atoms of nonmetals, with each other, with nonmetals, where ionic bonds are usually a nonmetal and a metal, or from opposite sides of the periodic table. The force that's holding them together is the attraction of each atom's nucleus and that shared pair of electrons. So like this example over on the right-hand side, fluorine and fluorine. Each of those fluorine atoms have 7 valence electrons. They can come together to share one set of them. And now when you count around them, you can see that each one has 8. Because they're sharing those 2 in the middle, they get counted for both sides. Sometimes they're going to share more than one pair of electrons. So there's different kinds of bonds. They all want to have 8, so they sometimes end up sharing more in order to reach that goal of having 8 valence electrons. If they're sharing 4 electrons, so it's 2 sets, 2 pairs, it's going to be called a double bond. If they're sharing 3 pairs of electrons, which is 6 electrons, then it's going to be called a triple bond. So there's double bonds or there's triple bonds. This oxygen example has a double bond because they're sharing those 2 pairs of electrons. Carbon dioxide also has double bonds because they're sharing those 2 pairs of electrons. And then the nitrogen for N2, those are going to share 3 pairs, so that's going to be called a triple bond. Molecular compound is a compound that's composed of molecules. So when they're bonded together and they're made into compounds, they're called molecular compounds. Okay? When they're covalently bonded, that means that they're sharing those electrons. We're going to call them molecular compounds. Okay? Generally, they're different than ionic compounds in how they're broken down and what kind of properties they have. Molecular compounds have a lower melting point and a lower boiling point than ionic compounds. Part of that has to do with the fact that it's nonmetals bonded together, and part of that has to do with the fact that it's not just the way they're sharing their electrons rather than kind of giving them to each other. Molecular compounds do not conduct electricity when they're dissolved in water. So they do not conduct electricity in the way that sometimes ionic compounds do. They have an unequal sharing of electrons sometimes. So when we talk about that, what we're talking about is if I have 7 valence electrons and you only have 1 and we're sharing them, my having 7 is going to have a stronger pull than you only having 1. And so it's going to end up making it a polar type molecule. So when they share evenly, there's not a positive or a negative side of the compound. But when they don't share evenly, one side is going to pull the other side. So this example here, when they're talking about a polar bond, hydrogen and fluorine. Fluorine has 7, hydrogen has 1. So there's an unequal pull pulling the electrons towards the fluorine side of that. And so that's going to make a positive and a negative side to the molecule, which is called a polar bond. Okay, nonpolar is when there's no specific positive or negative. Polar is when one side is positive and one side is negative because the electrons are being pulled more to one side. So when we have polar bonds, we have more attraction between the molecules. Okay, nonpolars do not have the pole, like the positive and negative pole to each other. So think about magnets, right? Magnets have a north and a south side. So they have different poles, or a positive and a negative side. They want to bond to the other's magnets because of that, okay? Whereas nonpolar things that are not, so non-magnetic things, are not going to want to bond to them in the same way. Water's a polar molecule. So water molecules have a tendency to kind of clump up together because of that, because they are polar and they have a positive and negative side, so they work similar to magnets. Oil is nonpolar. So an example, when you mix oil and water, the water molecules go together, but they don't really go with the oil, so oil and water don't mix because oil is nonpolar and water is polar. So the ones that are polar are going to bond to each other or be attracted to each other because of that ends that are like a magnet. All right, this wraps up chapter 5, section 3. We're looking at covalent bonds.